Okay, given that alpha is an angle in standard position whose terminal side contains the given point, provide the exact value of the indicated function. So we want to find cosine alpha, and alpha's terminal side contains the point 6, 8. So we can draw this. 6, 8 point. In standard position, the terminal side of alpha. Okay, good. So let me draw this alpha a little bit smaller because I'm going to make a triangle here. So that's alpha. We've got a triangle where this side is 6. Do a different color. 6 and the side is 8. And Pythagorean theorem allows us to get the hypotenuse. That would be 36 plus 64, or c squared equals 100, so c equals 10. So we can put a 10 for the hypotenuse. Great, now cosine alpha. Cosine, we have SOHCAHTOA. Specifically for cosine, AH, that would be adjacent over hypotenuse. That's cosine. So from our perspective of alpha, adjacent is 6, hypotenuse is 10. So we have cosine alpha equals 6 over 10, or 3/5. That completes this problem. Find sine alpha if alpha is in standard position and its terminal side includes the point 5, 6. So we start by drawing 5, 6, and a point at 5, 6, the terminal side of alpha. So this is alpha, and we have our triangle right here. So let's draw this triangle a little bit different. So that's 5, that's 6. Then what is x? We have x squared equals 5 squared plus 6 squared. So x squared equals 25 plus 36. So x squared equals 61, giving us x equals square root 61. So we can put this up, square root 61 alpha. All right, from SOHCAHTOA, we have that sine is opposite over hypotenuse. From the alpha's perspective, opposite is 6. Hypotenuse is square root of 61. So we have sine alpha equals 6 over square root 61. Now, a lot of books want to have this rationalized. Some books say it doesn't matter. I'm of that opinion as well, but since so many books say that it does, I know how to do this well as well. So sine alpha equals, now if you multiply by a form of 1, you're not changing the value of the expression. In this case we get square root of 61 times square root of 61. That gives us just a 61 denominator. The numerator is 6 square root 61. That completes this picture. Find tangent alpha if alpha is in standard position and its terminal side includes the point -7, 5. So we can start by drawing this. This is the point -7, 5. And we can draw a triangle. Now, technically, that's alpha. However, we can work with this value, the reference angle, and know that we will get the same value for tangent, assuming we have the correct signs. Now, and I don't mean SINES, plus minus signs. X is -7, So if I label this -7 and I label this 5, then the signs have been taken care of. Now why I would label this one -7 is because it's left. This is +5 because it's up. And the hypotenuse will always be positive. Working out the hypotenuse, we have x squared equals -7 squared plus 5 squared. That is 49 plus 25, which is 74. Now that we have, actually we didn't even need that as I'm thinking about it now. From SOHCAHTOA, tangent is opposite over adjacent. From the perspective of theta, opposite is 5, adjacent is -7. We actually didn't need any of that work. But you don't know, and in general, I mean, it's correct that this is the square root of 74, but it's not needed for tangent. And had I thought about it, I would have skipped that. But you usually just kind of go through the motions and don't always need to use everything you find. Tangent of alpha is going to be 5 over -7, and I could put the negative out in front. Now you might be saying, wait, that's tangent of theta, but theta is the reference angle of alpha, and so it'll be the same answer other than plus minus, and we've already taken care of the pluses and minus by making sure the 5 is positive and the 7 is negative. You can also make sure that it's right by thinking of the all students take calculus, where of sine, tangent, and cosine, all of them are positive in quadrant 1. Only sine is positive in quadrant 1, telling us that tangent will be negative. Perfect. And tangent's positive in quadrant 3. I said that wrong. Only sine's positive in quadrant 2. Only tangent's positive in quadrant 3. And only cosine is positive in quadrant 4. It's a nice way to verify your signs. Find the exact value of the following expression without using a calculator. Okay, so let's first draw this so we know what value they're after. 5 pi fourths is this one. 5 pi fourths. I know this because the pi fourths, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. There's our 5 pi fourths. Now, what is critical is, first off, so alpha is the reference angle. So I can call this alpha. That doesn't look like an alpha. It won't undo. Wow, it sure did. Let's try this again. How about just a little erase? Oh, this is going to be difficult. I can't erase anything. Okay, fine. The joys of technology. That's alpha. That part. Okay, sine, essentially, the reference angle theorem says that sine of 5 pi fourths will be plus or minus sine of the reference angle of just pi fourths. This angle right here is just pi fourths. We have 1 pi fourth right there. Now the plus or minus is depending on which quadrant you're in. So there's always going to be two steps. If your angle is a nice angle that you recognize from the unit circle, a fourth, a third, a sixth, a half, etc., in radians. If it is not in the first quadrant, you will need to do basically two steps. Step 1 is reference angle. In this case, it's pi fourths. Step 2 is quadrant. In this case, it's quadrant 3. This information will be enough for us to evaluate sine of 5 pi fourths, because the sine of the reference angle, pi fourths, is square root of 2 over 2. That's from the first part. What's the reference angle? Okay, what's sine of that reference angle? Got it. The second part, quadrant 3, all students take calculus. In quadrant 3, which was where we're at, only tangent is positive, which forces sine to be negative. And this two-step process will be how I do all of these evaluations of sine, cosine, tangent, secant, cosecant, cotangent, all of them. All right, let's do another one. Find the exact value, 4 pi thirds. 4 pi thirds is there. 4 pi thirds. I know this because the pi thirds, 0. There's 1 here, there's 2 here, there's 3 here, there's 4 here, and then 5 and 6. 6 pi thirds being 2 pi. So the reference angles, first step, reference angle, that would be 1 pi thirds. That's enough for us to know that cosine of pi thirds is 1/2. You do need to know the values of the basic 90, the first quadrant angles for sine, cosine, and tangent. Especially sine and cosine, because you can use those to find the tangent. So 1/2 is cosine of pi thirds. Now, all students take calculus. Tangent's the only positive one in quadrant 3, so we need a negative for ours because we're doing cosine. Two-step process. First step, reference angle. Second step, quadrant. This will get you the value and then whether it's plus or minus every time. Okay. Tangent pi thirds. Let me go over for a moment a tool that you can use, and it doesn't take too long. 0, 1, 2, 3, 4, 4, 3, 2, 1, 0, all divided by 2. This is sine, this is cosine, this is 0, this is, or 0 degrees. This is pi sixths, or 30 degrees. Let's try that again, 30 degrees. This is pi fourths, or 45 degrees. Pi sixths, pi thirds. Having trouble trying to do this fast. Pi thirds, or 60 degrees. And finally, pi halves, or 90 degrees. Now, the reason why I go over this is for our tangent pi thirds. I know that's sine pi thirds over cosine pi thirds. That's what we really need to work out. And this table, pi thirds, sine of pi thirds is the square root of 3 over 2. Divided by cosine of pi thirds. Cosine pi thirds is square root 1, or just 1, over 2. Now we can then invert and multiply and simplify and get square root of 3, which is tangent of pi thirds. Now this table can be used a little faster for tangent by recognizing that this divide by 2, when you're doing tangent, they'll cancel every time. So you can just do the sine over the cosine. Pi thirds, sine, square root of 3, cosine, square root of 1. The answer is square root of 3 over square root of 1. Square root of 1 simplifies, you just get the square root of 3. So if I wanted to do tangent of pi fourths, it would be square root of 2 over square root of 2, which is 1. If I want to do tangent of pi sixths, it would be square root of 1, or 1, over square root of 3. Tangent of 0 is 0 over 2. Makes it really easy to get sine, cosine, and tangent, and this little table is fast to write on the top of your test before you take it, or etc. There's some other things. There's a little hand way to do it with your right or your left hand. There's some fun ways, but this is a nice way, and it gets you tangent quickly. All right, moving on. Evaluate without the use of a calculator. Secant pi fourths. When you have secant, you want to think cosine. So that you can then get secant. So thinking cosine of pi fourths, the answer is either square root of 2 over 2, or 1 over square root of 2, depending on how you've memorized this. If you think cosine and get cosine, then you can get secant by just 1 over that. So you can either take this one and flip it and get 2 over square root of 2, or you could take this one and flip it because secant is just the reciprocal of cosine. So square root of 2 is the simplified answer. Now you might wonder, how could you get this to reduce to square root of 2? And one of the best fun little tricks you can do is change 2 into square root of 2 times square root of 2. That's what 2 is. And then one of those cancels. But either answer, depending on your book or your teacher, you might not have to rationalize the denominator, like this one's rationalized the denominator. You might be able to leave it with the square root in the denominator. But you need to know whether that's appropriate for your book or your teacher. I've shown both ways just in case. So when you have a secant, think cosine, get your answer, and then do its reciprocal or flip it. Okay, next question. Secant 120 degrees. Find this value without a calculator. So we want to think cosine. 120 degrees is right there. From that information, we have to get number 1, reference angle. That would be 60. Number 2, quadrant 2. This gives me the reference angle of 60. Cosine of 60 is 1/2. Quadrant 2, cosine is negative because of all students take calculus. Sine's the only positive one in quadrant 2. So we get cosine of 120 is negative 2. So now we can get secant of 120 is, flip that, negative 2 over 1, or just negative 2. So when your angle is outside of the first quadrant, you have to think in terms of reference angles and quadrants. The reference angle gives you the value, and the quadrant gives you whether it's plus or minus. And secant then is 1 over cosine, and that finishes the job. Great. Find the exact value of the expression. Sine 5 pi fourths over cosine 5 pi fourths. Now, you can just start working with sine and working with cosine, or, and that's fine, and I'll probably do them both ways, or you can recognize that that's tangent. Sine over cosine is tangent, as long as it's the same angle. Great. Now, 5 pi fourths is here. That's 5 pi fourths. The reference angle is pi fourths, and we're in quadrant 3, where only tangent's positive. That's from all students take calculus. Okay, so tangent will be positive. All right. Now, tangent of the pi fourths, sine and cosine are the same at all the pi fourths. They're 1 over square root of 2, or square root of 2 over 2. So when you go to tangent, your sine and your cosine will cancel and give you 1. You only have to worry about the sine now. So the reference angle gives us the value of tangent will be 1, but the sine, since we're in quadrant 3, tangent's positive. So that's it. Now to see this in a little bit different perspective, we could also work out the sine and the cosine separately. Sine of 5 pi fourths, quadrant 3, reference angle pi fourths, would be negative square root of 2 over 2. Cosine of 5 pi fourths, quadrant 3, reference angle pi fourths, is also negative square root of 2 over 2. This reduces to 1. So that would be another way you could do this. In both cases, you do have to figure out what reference angle, what quadrant this 5 pi fourths is in. When it comes to reference angles, radians make it very easy. If you have a divide by 4, pi, 5 pi fourths, 7 pi fourths, whatever pi fourths, your reference angle is a pi fourths. If you have a pi thirds, your reference angle is pi thirds. If it's a pi sixths, your reference angle is pi sixths. Radians make reference angles very easy. All right. Find the value cosine of pi halves minus pi thirds without the use of a calculator. Now some of you might be thinking that you know the difference angle identity for cosine. You could do it that way and it would take you about 5 minutes longer than the easy way. The easy way is order of operations says do what's inside the parentheses first. Well, pi halves minus pi thirds is no more than a fraction problem. 3 pi sixths minus 2 pi sixths. That's pi sixths. So in other words, we're not looking for cosine of pi halves minus pi thirds. We're actually looking for cosine of pi sixths, which is just square root of 3 over 2. That's all there is to this problem. To use a calculator to find a function value, to 4 decimal places in this case, you need to first make sure you're in the correct mode. If the number, the angle inside the cosine has a degree symbol, then make sure you're in degree mode. If it doesn't, even if it looks like a degree, then it's radians. It has to have the degree symbol, and furthermore you have to write the degree symbol if your answer is going to be degrees instead of radians. In this case, make sure your calculator is in degree mode, which mine is. Now your calculators, if you turn your calculator on and there's a 0 on the screen, that usually means that you have to write the 42.7 first, then you hit the cosine. If that works, and that gives you the 0.7349, you've got it figured out. Now if you write the 42.7 and then hit the cosine and it shows on your screen cosine parenthesis, then you know you need to actually do the cosine first. So that's what mine does. Cosine, and you type in 42.7, close your parentheses. This is hopefully all of your test questions are this easy. 0.734914, etc. 4 decimal places. The 9 does not get rounded up, so 0.7349 is your approximation. Alright, find the value to 4 decimal places using your calculator. Notice this time there is no degree symbol, so this is radian. 3.13 radians. 3.14 is pi, so this is just about sine of pi, which is just about 0. So expect something small out of this one. But it's not exactly pi, so our answer is not exactly 0. Let's find out what it is. So make sure you're in radian mode. I am now in radian mode. I then hit sine and 3.13, and it gives me a small number, 0.0115923, etc. We want 4 decimal places. The 9 rounds the 5 up, so it's 0.0116. That decimal down a little more. Alright, that's it. So the key to these, make sure you know if you're in degree or radian so you can set up your calculator in either degree or radian mode. Find the exact value of the expression. Do not use a calculator. Cosine theta over 8 if theta equals 45 degrees. Okay? So essentially what we need to do is we need to take this 45 degrees and plug it in for theta. I'm going to write this 1/8 though. It'll make it a little bit easier with all the fractions that happen often with these. So we have 1/8. Cosine 45 degrees is square root of 2 over 2. So this then multiplies 1 times square root of 2 is square root of 2. 8 times 2 is 16. And that's it. Simple problem. Find the exact value for tangent alpha if sine alpha equals -3/5 and cosine alpha is less than 0. Okay, so let's figure out where alpha is first off. All students take calculus. Notice we have sine is negative and cosine is negative as well. Where could that be? Well, they're all positive here. Here sine's positive, here cosine's positive. Quadrant 3 is the only place where sine would be negative and cosine would be negative as well. So we are in quadrant 3. So let's draw a little quadrant 3 angle, like that. Call it alpha. Now, next, SOHCAHTOA tells us, reminds us that sine is opposite over hypotenuse. We are given sine. From alpha perspective, sine is opposite over hypotenuse. So the opposite, we have 3 and we have 5. Which one's negative? Hypotenuse is negative, never negative. The 3 is negative because this is down. Down's a negative direction. Okay, now we have to figure out the third piece of this right triangle. We have x squared plus negative 3 squared equals 5 squared. That would be x squared plus 9 equals 25, giving us x squared equals 16, so x is 4. Plus or minus, in this case it's minus, because left is a negative direction. Left and down are negative directions, that's why we have these two negatives. However, the hypotenuse is out, and out is a positive direction. In is a negative direction, and there is no in if you start at the origin, it's all out. So left negative, down negative, out positive. Hypotenuse is always positive. And we get to find tangent alpha. Now tangent, opposite over adjacent. From alpha's perspective, opposite is negative 3, adjacent is negative 4. So we can get tangent alpha equals negative 3 over negative 4, which reduces to 3/4. This is positive. We're in quadrant 3 where tangent is positive. Everything works out great. Find the quadrant that contains the terminal side of alpha. So we have cosecant, think sine, sine greater than 0. Secant, think cosine greater than 0. All students take calculus. Where is sine positive and cosine positive? Quadrant 1. It's the only spot where they're both positive. That was easy. Great. Find which quadrant the terminal side of alpha lies, given that cosine alpha is greater than 0 and cosecant alpha is less than 0. Again, with cosecant, you don't want to think sine. So, all students take calculus. This, by the way, isn't necessarily true. If you're taking this for something else besides engineering, you might be done at calculus, and then you might consider saying this, all suckers take calculus. But not me. I took calculus and many more beyond. So I love calculus. It's a great course. Let's figure out what quadrant we're in. We have cosine's positive. Cosine's positive either quadrant 1 or quadrant 4. Sine is negative in quadrant 4. Out of those two choices, this is the spot where cosine's positive and sine is negative. We are in quadrant 4. Excellent. Determine which quadrant the terminal side of alpha lies. We have cosecant, and I want to think sine. Sine alpha is less than 0. And cotangent. Think tangent. Tangent alpha is greater than 0. The reason why we can think the reciprocal functions is if cosecant is negative and I flip a negative number to get sine, it's still negative. So sine and cosecant will be negative in the same spots. Tangent and cotangent will be positive in the same spots. Secant and cosine will be the same sign, plus or minus, in the same locations. It's easier to think that way, especially with this all students take calculus shortcut. So we need to find the location where tangent is positive and sine is negative, and there's only one spot. Tangent's positive only tangent's positive. Tangent's positive in both quadrant 1 and quadrant 3. Sine is negative of those two choices in quadrant 3. Quadrant 3. Okay, great.